Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another problem. Let me give you the first problem, then we will discuss the solution. Problem says figure A. I will give you the figure. Let me write it. Shows a charge Q1 of plus 1.5 microcoulomb and a charge Q2 of plus 2.3 microcoulomb. When problem goes like this, the first charge is at the origin of an x-axis and the second is at a position x equal to L, where L is 13 centimeter. Then question says at what point P along the x-axis is the electric field Z. Let me draw the figure. This is my x-axis. So one charge is placed at origin, and this charge is named as Q1. The first charge is at the origin, that means Q1 is at the origin of the x-axis, so it is origin. Right? Then second charge, which is also positive charge, Q2, is placed at x is equal to L. That means this distance is L. This is my figure A. So let me check the problem. So it says figure 1 shows a charge Q1, this is Q1, of plus 1.5 microcoulomb. It is positively charged of magnitude 1.5 microcoulomb, and you know 1 microcoulomb is 10 raised to power minus 6 coulomb. And a charge Q2 of plus 2.3 microcoulomb, which is this Q2. The first charge is at the origin, Q1 is at the origin. The second is at a position x is equal to L. So for Q2, coordinate is L, and L is 13 centimeter. Now we are asked to find point P along the x-axis uh, at which the electric field is 0. This is our problem. You know, first, if we have a point charge Q and we select some point P, our distance from the charge, we are discussing now first solution. Now at point P, electric field magnitude is given by 1 by 4 by epsilon naught Q by R square. You know that. And direction of the field is outward if this Q is positive. And if Q is negative, direction of the electric field is radially inward. You know that much. Now let us move to this situation. Now, if first we want to justify the point which we are going to find, point P at which electric field is 0, it must lie between the charges because only in this region do the forces exerted by Q1 and Q2 on a test charge oppose each other. Try to understand it. This point P cannot be this way, this on this side of the x-axis, because here field due to Q1 is towards left and field due to Q2 is also towards left, so they cannot cancel out. Similarly, this point cannot be to the right of Q2 on the x-axis. Same problem, electric field due to Q1 will be outward, electric field due to Q2 will be outward, right? So these possibilities doesn't exist. So that point P, therefore, must lie between the charges because only in this region, field is due to Q1, Q2 oppose each other. So this point P, suppose this point P which we are going to find is at x distance from Q1, right? That x distance from Q1. So at point P, you can see the electric field due to Q1 is E1. This is this way. E1. And electric field due to Q2 is this way, right? Now we have to find x now. How we can find x? We know the only way electric field, net electric field at point P is 0 is that the magnitude of E1 and E2 at P are equal, right? E1 is electric field due to Q1, it is this way. E2 is electric field due to Q2. We are saying that point P be x distance from origin from Q. So we will use the expression for electric field due to a point charge and equate these magnitude of the fields E1 and E2 to solve for x. So let us do that. So we equate the magnitude of E1 with the magnitude of E2. So that is 1 by 4 pi epsilon naught Q1 by x squared. Because this point is x distance from Q1. But it is how much distance from Q2? It is L minus x distance from Q2. So on the right side, we will write, let me use another color. It is 1 by 4 pi epsilon naught Q2 by L minus x squared, right? Because distance of the point from Q2 is L minus X. This distance is L minus X, this distance. Right? Got it? So let us move. 1 by 4 by epsilon naught, Q1 by X square is 1 by 4 by epsilon naught, Q2 by L minus X. So when you make this, we have to solve for X. So when you make that solution, you will get X equal to L over 1 plus square root of Q2 by Q1. L by 1 plus square root of Q2 by Q1. So let us put the numbers. Our L is 13 centimeter, and then we have 1 plus square root of 2.3 microcoulomb over 1.5 microcoulomb. This is in the square root. Because our Q2 is 2.3 microcoulomb and our Q1 is 1.5 microcoulomb. So 13 centimeter over 1 plus square root of 2.3 microcoulomb over 1.5 microcoulomb. When you make this calculation, it turns out to be 5.8 centimeters. As always, you have to check it at home. Check it at home. First check from this X, convince yourself that X from this equation is equal to L over 1 plus under root Q2 by Q1. Then make this calculation and solve these numbers. You will get X equal to 5.8 centimeter. Now L is 13 centimeter. As we said in the beginning, that point P must lie between the charges. Now convince yourself from the solution. Firstly, X is positive and is less than L. Positive means it must be to the right of origin, and since it is less than L, L is 13 centimeter, that justifies our position that this point P is between the charges. Got it? I repeat, X is positive, that means it is the right of origin. X is less than L, that means it lies between Q1 and Q2. So I hope you got this problem. So enjoy these problems at home, and don't forget to like, share, and subscribe my channel. You can comment in the comment box as well. Thank you. God bless you. Assalamu alaikum.